Hello everybody. Today we're going to discuss the difference between accuracy and precision. Accuracy means to be close to a correct or agreed upon or accepted value. For example, if you were performing a lab where you recorded the density of an object and you recorded a density of 2.6 grams per milliliter and the accepted density for that object is 2.7, then you were accurate. You are pretty close to the correct answer. A thing to note, when you're dealing with accuracy, you should always look at the average of your data points. If you only have one, of course, that is the one you are comparing, but if you have multiple, you should consider the average of those data points when looking to determine if you are accurate. Precision means that collected data points are close to each other. So generally, precision can only really be assessed if you have multiple data points. You can also consider how many significant figures are present as a way to assess some of the precision, but you really truly would need multiple data points to really know. So for example, if you did a density lab similar to the one described on the previous slide, and you collected data points of 2.51, 2.54, 2.49, and 2.53, you would be precise because the difference between the largest and the smallest here is 0.05. That's very small compared to the size of the values that are here. So since the difference between all these data points is very small in comparison to their own size, you would be considered precise. So let's look at the following four images and determine which ones represent accuracy. Accuracy means being close to a true or target value. Specifically, since there are multiple darts on these images, we would look for where the average is. And so while we can see that the far right clearly is accurate because they're all right near the edge of the bullseye, there is one additional one that technically represents accuracy. The middle right one, or the third one from the left, also represents accuracy. While the darts are out on the outermost white ring, their average point is very close to the bullseye, so this one also represents accuracy. Let's look at these same four, but now let's try to assess which one is representing precision. Again, the far right appears to represent precision. They are all on the bullseye, but there is also one other that represents precision. The one that is second from the left, or the middle left one, has precision. The 4 points are very close to each other, either on the outer white ring or the outer red ring, and they're very close to each other. A reminder that accuracy and precision are not the same thing. We identified different images to represent accuracy and precision on the previous slides. One of these images represents a situation where you have both accuracy and precision. It's the one on the far right. All of them are close to each other, so they are precise, and their average is on the bullseye because all of them are also on the bullseye. So the far right is both accurate and precise. There are also other situations. The second from the right happens to only be accurate. It is not precise. Those data points are too far away from each other to be considered precise. The second from the left, however, is only precise. Their average is very far away from the bullseye, so they cannot be considered accurate. And the image on the far left, which we have not labeled yet, is neither accurate nor precise. So what does this mean if we have data points? Let's look at an example set of data, again using density. You collected data for the density of a block of aluminum. The densities you recorded were 2.31, 2.33, 2.28, and 2.34 grams per milliliter. The accepted density of aluminum is 2.70 grams per milliliter. Are these data accurate and/or precise? If so, why? This is technically two different questions. We have to ask ourselves, are the data accurate and are the data precise? We'll answer precise first because that one's usually the faster one to answer. Since the four data points are all relatively close to each other, with the biggest difference between them being 0.06, they have a very small difference. They're pretty close together, so this data would be considered precise. We could double check this by performing a standard deviation calculation and seeing that the standard deviation is also relatively small compared to these values. However, let's look at accuracy. We were given an accepted value of 2.70 grams per milliliter for the actual density of aluminum. And these data points are somewhere between 0.3 to 0.4 grams per milliliter away from that accepted value, which is getting a little bit large compared to the size of these data points. So this data is not quite accurate. Please note that you do need an accepted value to compare to in order to assess accuracy. If I did not know the density of aluminum, I would not be able to answer whether or not the data were accurate. Good luck!